Welcome back, everyone. Good to see you all here, or at least I can't see you, but I'm sure we have viewers in our live event. Fabio Ricchiuti, you are with us, right? Do I still pronounce your name correct, or is it incorrect?
Perfect.
Perfect, even. Oh, I practice on it.
Very proud.
All day. So you're going to talk about your presentation, experimenting in a distributed ecosystem, right? Do you have maybe 2 sentences that you can tell us what you're going to talk about?
Yes, I'm going to tell what the team XPMT made for you to ensure that you have a smooth journey in setting up experiment.
All right, sounds great. Then it's up to you. I will leave the stage and you can take the virtual stage.
Awesome. Okay, I'll share. Okay, so I hope after a morning of talks, you're still very eager to learn about experiments. So let's get to this. And I will start with a bold question today. So the question is, are hippos and zebras driving your innovation? Well, don't get too scared. We didn't start hiding animals. The term hippo was created by the experimentation team in Microsoft many years ago, and it stands for highest paid person opinion, and describes the fact that when hippos are mainly involved in decision making and there is not enough data available, the teams tend to rely on an experience or also on gut feeling, which is not a bad thing per se, but sometimes this might bring to lose contact with what the user needs. So if zebras are added to the mix, they become really an evil duo, because zebra stands for zero evidence, but really arrogant. So how can we make sure that we keep control over them? Well, looking at data, of course. And actually, the real truth lies in the user interaction, because our product translates into user interactions, every product. And the good news is that in Bol, we have plenty of them. There is a data source called M2 that's maintained by a team also named M2, which gathers up to 5 terabytes per day of user events like clicks, views, render, and so on. But not only, we also have a commercial tool called Adobe Analytics, which many teams also relies upon. And we also have other data, backend data, like the one that we store, such as customer data, order data, purchase data, and so on. So what can we do with all of this? Well, experiment, of course. And a simple methodology that we really like, it's A/B testing. It's a way in which you come up with an hypothesis, how to improve a web page. You build a new variant, and you try to understand if this would be better for the users. Usually, the user are split 50-50, but can be even more variants. And we call this process bucketing. We measure the performance of the variants with the mean of a metric. The most commonly used metric is conversion rate, that measure how often a user visit translates in a bought product. And this method becomes really effective when you actually you have a setup that allows to experiment fastly and often. And because a small experiment, other than being easier to set up and being more effective because the changes are more isolated, it will also lead to be able to gain little percent often. And if you manage to do this every day or every week, at the end of a set amount of time, it will compound to a huge surplus that will overtake certainly your organic growth. And also what's important is that failing is part of the process. And we could see leading companies out there running more than 10,000 experiments annually. And only a little part of this experiment actually end up proving the original hypothesis. And all the other experiments that are backed by wrong hypotheses, that's actually where we learn the most, because that's where our assumptions are challenged. So our favorite motto is work smarter and not harder. And how to achieve all of this? Well, first of all, you are not alone. We are here to help. I'm Fabio, software engineer in team experimentation. And I work with this group of enthusiastic people in the best way to meet your experimentation needs. And also our team will grow very soon. And today I'm going first. I want to talk about what we offer as a team, which kind of nice product we built. I'm going to explain about the bucketing. That's the main building block of an experiment setup. Then I'm going to guide you through the step needed to have an experiment up and running. And then we are going to zoom out a bit and see how this will work from architectural perspective with other services. And then finally, I have other cool stuff that I want to pitch about experimentation. So let's get to what do we offer. Well, first of all, we created a super cool platform that you can reach on experimentation.bol.io. And that's where you can administer your experiment, you can configure them, you can also store your learnings and explore other teams' learnings. We also provide automated analysis and dashboard based on M2. That's our official data source, but that doesn't mean that if you're going to need other kind of data source, we're not going to help you. We're still going to find a way to set up an experiment. Plus, we have tons of documentation, and there is also an e-learning that's provided in StudyBol. And of course, you can always reach us out for a question on the experimentation support group. And lastly, but not least, we also maintain a set of libraries, precisely 2 libraries, the bucketing client and the beacons client, that I'm going to tell you a bit more in this talk. So let's start with the bucketing. The bucketing is provided in a Kotlin library that you can just pull from Artifactory, and it encloses a client that will pull experimentation.bol.io for learning about new experiment. And we designed it this way so that when you're serving a request to your user, for executing the traffic split, there is no need to have external HTTP call required. So experimentation will never break your normal flow. And plus, you can execute with this client smart bucketing, and we define it smart because it consistently split users over multiple variants, and you can identify the user through anonymous ID, like browser ID, or user ID for logged users. Then that's depend how you're going to set up the experiment, if you want to learn from anonymous users or logged ones. And also, it gives you the freedom to place the bucketing strategically in your code to define a clean scope. And I'm also going to tell a bit more later on. It's important to specify that this is a stateless operation. That's because the bucketing happens through an hashing function that translate the experiment key and the subject identifier into a number. This number is going to be from 0 to a total allocation, and depending on where this number falls in the range, it will be associated to a variant. And that's nice because, first of all, we don't need to store anything about this. If you execute the bucketing multiple times, you're going to get always the same result. And there is also a degree of predictability. You already know in which bucket the user will end up before the experiment is run. So now that we know about how the bucketing works, we can actually look which step you need to take to set up an experiment. But before starting, there is a requirement. You need to make sure that your front end is measured. So now this step can be fairly easy. If you're going to execute an A/B test on a part of the website, for example, that is already been included in other experiment, then you don't need to do anything. You're just good to go. If you are pioneering on some unexplored path, then you have to plan some work ahead, but it's going to be one-time investment, and you're going to make a lot of colleagues happy. So if you have questions on this, it's to reach us out, and we're going to proxy your request to other teams that can also help you. So let's start with the first step. You can just go on the experimentation.bol.io. You can create the experiment. You are going to add the basic information like the title. You can also configure the experiment with the start date, it's kind of the traffic split that you expect. And you're going to define a key, an experiment key, usually is something like a Jira ticket. This key will identify the experiment for you. And then we can move to actually set up the experiment. And here you can just reference the experiment key in your code. You can just hard code it or assign it to a variable. Now, before actually executing the bucketing, it's important that you check the experiment scope, that you check that the flow of your request is valid for serving this experiment. And there are two pitfalls that you need to take in account in this case. The most commonly one that we saw is selection bias. And selection bias happens when the user are not divided among the variants according to the expected probability. So you expect that the user are 50-50, are the same amount in both variants, but actually in treatment there are less users. And this happens if there is some consistent error, exception that leads the content to not be rendered, or if your content in the treatment is depending on a service that doesn't respond. This will make the experiment have skew data, and you will not need to rerun the experiment again. The second pitfall is assignment dilution, and this happens when you're including experiments that are not relevant for what you want to learn. So for example, you are bucketing on the page render, but you only want to learn about select users. Then in this case, you want to execute the bucketing when you know that the user are select users. So this will, if you don't do this, it will pollute your data, and your experiment will lose power. Well, now that you check that these conditions are satisfied, they are true, then you can call the experimentation library, call the get active variant method, pass the subject identifier and the experiment key, and then the final part is just about sending the variant to M2, to your data source, and actually performing the implementation of your new variant, or give back the regular variant, the legacy feature. Now we talk about measurement, but what actually is a measurement? A measurement is a snapshot that represents what the user sees in a moment of time, or the action that he or she have executed. And therefore, we need to map this snapshot to a variant so that we are able to query afterwards and to aggregate all this information in a metric. So a measurement is usually a JSON-like message. What you see in this example is just a snippet of an M2 measurement, and it is initially sent by the user-facing backend, and then it is enriched by the front end. And in M2, for example, they are all sent to a Kafka cluster, and often it's more than one measurement per request. So you can understand that this will create a huge amount of data that will be eventually stored in a data warehouse like BigQuery. So that's where our daily job, XPMT daily job, kicks in. That serves two purposes. It aggregates all of this interesting information to a smaller data set that you can afterwards query to execute your custom analysis. You can query faster and cheaper, but also make it available for being displayed on the experiment result page. And that's where you are going to see all your amazing insights. First of all, there is a report section where you can look at the metric, you can understand whether the conversion went up or down, but there is also an exploration part where you can see the information about the user visit, you can see which kind of order were made, how many orders were made, or other interesting action like add to carts or wishlist add. So that's what you need to know to set up an experiment in your service. But let's zoom out and see how this will work out on a bigger scale. So, well, this is a fairly simple way to serve experiment. We have a user that comes in and makes a request to the web shop, or to app, or to a partner front end. And this request is fetched, and the subject identifier is parsed. That in this step should be salted and hashed to protect the identity of the user. This ID together with the request now is sent to all the services it wants to do experiment, so included your service, of course. And in this context, your service will execute the bucketing. We'll already know of the experiment was activated because it pulled this information right before. And then the service will send the response back with the activated variant. And the front end will flash this information in M2. Now, this is simple and nice, and it works well if you're also maintaining the front end in your team, in your OpEx. But for other kind of situation, actually, it was a problem in the past. We actually saw some pain points with this approach. And those pain points arise from the fact that only user-facing service can publish data on M2. So that means that all if you are later in the call chain, all the service downstream will need to return the variant back to the front end, then we'll add it afterwards in M2. So you will be depending on these teams. And additionally, if async requests are involved in this experiment, so there is no doesn't need to be an immediate response, then this will be even more complex for setting up an experiment. So how can we make this better? Because we want to achieve the fact that your service is autonomous in bucket users and also autonomous in linking the activated variant to the measurement. So how can we decouple it from the front end? Well, there is a way to do this. Let's go back and looking at the measurement. And there was a variant before in the field active A/B test. Now we can get rid of that, and we introduce a new ID. It's just a random ID, that's random string that generated per request, and we call this XPMT beacon ID. The XPMT beacon ID, you can see it really as a foreign key, speaking in a database lingo, and it's a foreign key to associate the which variant were activated in the for that particular request. So now the experiment flow will go as follows. We have a user making a request to the front end. The front end will generate this XPMT beacon ID and will immediately send an initial measurement with this beacon ID associated to it. Then it will forward to all the service that wants to experiment, including yours, the subject ID and the beacon ID. And now the bucketing will be executed as before, but the difference is that the result of the bucketing will be immediately published on a topic that the experimentation makes available for you. And after that, of course, your service will be able to send the normal response to the front end, and the front end will compute the response and show it to the user. Of course, to have this working means that your service needs to receive this identifiers, especially if you are later in the call. You need to make sure that those service all forward those headers to you. But we find a way to make this easier, more automated, and we found out there is a super nice tool called Spring Cloud Sleuth that provide auto configuration for distributed tracing. And distributed tracing is nothing more than logging a message over multiple services. And among the capabilities of this tool, there is also a way to automate the forwarding of certain headers. So it will automatically map the experimentation header from incoming connection to outgoing connection. So going back to your service, what it will be doing basically two actions. From one side, it will sending back variants to the front end, and the front end will generate measurement with beacon ID and send to M2. From the other side, it will be publishing beacons. The beauty of using a PubSub topic is that you can really choose your own pace in performing this action. So if you decide to send beacons real time, or decide to batch the beacons and send them 1,000 at a time, that's still possible. That's because on the other side of the topic, there will be a streaming job built on Dataflow that will keep listening to what's published on this topic and will copy over on the BigQuery table. And that's where the daily job will kick in and then merge all this information together to be consulted on the experiment result page. Now, all of this can be easily implemented by you, but of course, we also provided a library, and in this library, we'll avoid you to do this hard work. and it's called XPMT beacons client, and it encloses the bucketing client that I explained before, but also include the Spring Cloud GCP pub sub, and it's implemented on Spring Boot, so it's compatible with your Axel services. And the main feature is that beacon ID are automatically fetched from the request, and that the beacon are automatically published when the bucketing is executed. So let's look at an example on how this can be implemented. So this is a classical Spring endpoint implementation, and what you can see here, there is this object called experimentation client request scope, and with the automatic power of Spring, you can initialize this object within your class, and it will be indeed the request scope, and that means that it will hold the beacon that is valid for that request. Since the beacon is parsed in there, what you need to do is just call the get active variant and send beacon method, and then the publish on the topic will happen automatically, and you will also get the activated variant back. And now you will just to render the actual content of the experiment. So this was more or less what you need to know to start setting up experiment on the technical side. Then I want to talk a bit more other cool stuff that we are building for you. And well, one interesting project that I've been busy creating a proof of concept with Stefan of Team 2. It's about having experimental data, health data on real time. That's because, as I said before, we have a daily job that kicks in every day. That means that for the first experiment data, you need to wait at least 24 hours. So we want to give you the possibility to learn about your experiment, to explore your experiment immediately. So we set up KSQLDB, that's a database built for streaming purpose, and Kafka Stream, that's a library for working with Kafka topics. And it sounds very, very interesting. Yeah, probably you will hear about this in some sequent talk. Then we're also coming with an approach for experimenting when the response are cached. So, of course, all I explained up to now, it will be more complicated in case you have a cache in front of your service. For this reason, we designed an approach in which you can spin up an experiment proxy, and this experiment proxy will decorate the response. And your cached object will have to contain, we call it experimentation deltas. So the variation of those fields, they should be changed for your variant. And therefore, the bucketing is executed when the response is fetched from the cache. Of course, this should happen in very performantly to allow you to still keep to send a response in a very short time. And after this, we're also going to work on add more customized metrics, but also give you the possibility to define your metrics directly from the UI without needing to make a new query yourself. And another interesting feature is going to be the possibility of ramp up your experiment. So you will want to try out a new variant only on a smaller set of users. So you want to, for example, try on the 5%, and therefore we want to add these capabilities of like a canary release. So to slowly ramp up and check what's going to be the reaction of the user, what's going to be the performance of the variant. And lastly, we're also working on experiment evolution that give the possibility to document the evolution of an experiment over time, to add new information when your hypothesis is changing, when you add new variants, and also to be able to have reports that compare how your hypothesis of 1 month ago performed compared to your new hypothesis. So that's enough for now. I hope that you enjoyed this, and I hope that this was enough to make your repos that driven and to make the zebra, let's say, a bit less zebra. Well, thank you for listening.
All right, thank you, Fabio, for sharing your story and presenting on Spaces Summit. I am looking on Mentimeter to see if we have any questions, but Fabio, I don't see any questions, so I guess you had a very clear story. Very good.
Awesome.
I also checked Google Threads to see if there was maybe discussion going on. Not yet, but you can always participate in it, right, Fabio? See if somebody has some remarks or later on questions, right? Because we're now right, maybe still the information need to sink in with people, and that they can start asking you some more questions on Google Threads.
I will be there.
All right, so good to know that you will be there. I checked Mentimeter once more, but it's still empty. So it was a very clear story. Thank you, Fabio, for being at the Spaces Summit and joining us from home, from your own Spaces Summit studio, right?
Thank you for my living room. Yes.
Yeah, all right.